Good afternoon. I'm Fuya Aybek Cetek from Eskişehir Technical University. I'm the coordinator of ATMACA Project, which is a grant communication, IT-based communication infrastructure development. And we will talk about today about the ATMACA concept and what we would like to achieve at the end of the project and current situation and technical backgrounds especially. And we will have, this is a webinar series. This is the first one. Thank you for your coming and for your interest. And now from the beginning, thank you for your questions and good feedback to us. We are waiting for your feedback and questions, of course. And this is first webinar, and we will explain to you concept of ATMACA and technical background and use cases of ATMACA project. And the second one will be held on around September, and we will, of course, announce that the second one. And it will produce to you the results of the project and results of our validation parts. So here we are. We are 4 persons from ATMACA team, from 4 different partners. And I will start with the introduction of the ATMACA concepts. If I may introduce myself, I'm ATM researcher, and basically I'm air traffic controller. And I continue with the research and development activities in my career at the university, at Air Traffic Control Department. We will continue with the row from DMU, De Montfort University, which is what is the motivation of ATMACA mobility management and protocol. And he is representing as an academic and technical background for the development of protocol ATMACA. And with Rosa Maria, we will continue for use cases of ATMACA project. She represents from University Politecnica de Madrid, and she's strategical perspective for operational feasibility and expertise air traffic knowledge within our project and within this webinar. And at last, we have from Turkish Airlines, Captain Pilot Sergun Özmen. And he is the owner of the project idea, actually, and he develops the ATMACA protocol, and he will deeply technical explanation background of ATMACA project. And at the end, as Philip said, we will have a question and answer session with 15 minutes with you. Yes, yes, here mine. And yes, go on. Sorry, it's a little bit slow. I would like to talk about the consortium of ATMACA. It is an exploratory research project, firstly. And Eskişehir Technical University is a coordinator and serving with ATM knowledge to this project. And we have 3 universities with ATMACA partners with Eskişehir Technical University 4, of course. The Montfort University, ATMACA, University of Politecnica de Madrid, and Eskişehir Technical University. And we have Deep Blue from industry and Serco and Turkish Airlines for the operational sides. We designed the consortium as a 3 legs and it's covered ATM knowledge for the exploratory research. Deep Blue will currently designing HMI development of ATMACA. And De Montfort University is working with Sergun and Turkish Airlines for the protocol design and implementation testing for the technical part. ATMACA is supporting to the project with the green routes operations, optimization and modeling. Politecnica de Madrid has a development of air traffic services and CPDLC application design responsibilities. And Serco is responsible for the validation and integration with their air traffic controllers. So we can, yes. Again, I should say that this is exploratory research project within the CESAR support, and its start date September, in the beginning of September in 2024, and we started with TRL1, and hopefully we will achieve the TRL2. The concept of ATMACA project is designing new approach and innovative protocol design for flexible to put any new applications for ATM ecosystem. It is innovative, as I said, technology supports, and it will support gate-to-gate communication during all flight phases, tower approach and route phases, and arrival, and again tower as well. So aircraft communication, we are serving via ground communication. It helps to give wind information to green routes operation optimization in our concepts. And what we are doing we have three part of solutions with ATMACA project, in the ATMACA project. The first one is data link protocol designing, which is technical solution. The data link protocol designing is a totally new design, and it should achieve all stage of the flights, and it should work all stage of the flights, and easy to implement any application such as CPDLC or airport operators applications, or as what we need in the future. So it's a technical solution. And we have some ATM solutions with the application services such as CPDLC, and getting the real time wind information from the aircraft, and giving this information to the ground with the green route operation application. And the last one is we are testing for HMIs. Of course, we have air traffic controllers and pilots in basically. So we are testing for, is it acceptable, that kind of communication for the controllers and pilots, and what is the new, and what is the challenge of the implementing this kind of application in the airspace. So this is a ATM solution. As far as everyone knows that for ATC, HMI design is very well defined, or defined until now. But the pilot part is not really supported yet. And we have Turkish Airlines support, and Sergun supports as a captain pilot from the cockpit. And Deep Blue and Turkish Airlines concentrate on HMI solution basically in the cockpit. How is it works in the future for the pilots. So here is three-step from ATMACA, data link communication protocol stage, and then application layer stage. And at the end of this project, we will serve green route operation and CPDLC applications only. But in the future, we hope and we believe that any kind of small, not small, easy application design, and it can implement directly the protocol, and it can serve any airlines operators or airport operators. And we are testing that, is it working, or what is the real pictures of the ecosystem with, of course, HMI. We have flight deck HMI, tower and radar HMI, and ATM management station HMI at the end of this project. So we are designing a small ecosystem in the small aviation ecosystem in this project, and it can be with the next TRL level, or within the next future projects, develop and put new application on this area. So how about the data link protocol, our technical solution? It should be served, ATMACA provides connection management and for user login, such as pilots or any air traffic controllers. And there should be a session management. It should be dynamically and automatically changing sessions between controllers and pilots. During the flights, pilots is switching the communication, of course, and between the air traffic controllers, it will switch off, hand off via automatically. And deeply information will explain via technical part, of course. For the mobility management, we will remain all user information within their user login, and we will keep the all information regarding the user services. So, how about the ATM solution for the application part? Firstly, if we are talking about air ground communication, of course, we need the CPDLC application. So there is a lots of CPDLC application around the world. So currently, they are working, but we try to how can I say, develop a CPDLC application and test how it works with new our protocol. That's why with Politecnico de Madrid we developed this application and testing the progress. CPDLC application should include, of course, all communication phases and all information between air and ground. And about green route operations, it's a kind of example that ATMACA, what kind of thing in the future can serve. The most important thing in the long flight phases especially is a green route and reduce fuel, of course, for the wind information. We can get real wind information from the cockpits, not this in the project, of course, real ones, but if you can connect directly the cockpits for the near real-time wind information, the route calculation could be better for the fuel consumptions. And we prove that with the green route operations part on that, this power of the project. And lastly, of course, we have HMI solution. We will try everything with HMI, with the real controllers and pseudo pilots in Serco simulations facilities in the real-time simulation. And we designed with Deep Blue, of course, Deep Blue designed the human-centering design for what they need, especially pilots and controllers, of course, and feedback engagement. And we designed the small, colorful, and flexible communication panel for all phase of the flights. And let's talk about the expected benefits at the end of projects. It's focus directly to the digitalization, of course, for European vision, around the world vision, of course, and CESAR vision especially. We are digitalizate the communication between air and ground. It's not include only pilot and air traffic controllers, of course. Data management and data communication is very important day by day. So within the ATMACA concept and protocol, we will design, as I said, green route operations what application, and it serves for the optimize the capacity, which is new collected data and the best route for the per aircraft. And of course it will increase the efficiency for the Europe aviation. And with the mobility management strategy, the controllers and pilots communication will be more efficient with that. So and safety, of course. We are, of course, there's some voice problem in VHF system, and accent or English problem. And within the text communication, safety will be more reliable, and the communication will be more reliable, and it's a benefit for the safety parts. And the fuel consumption regarding the application of green route operations and temperature data, we optimize the route, then it will save the world, save the earth, and save the emissions and fuel, reducing fuel consumption, of course. And it serves the green route operations part, serves more reliable estimate of time of arrival. It means that more good planning for TME and reducing holding points or any deviations in the terminal airspace. And operational efficiency for user-friendly HMIs, pilots can monitor during the flights, and pilots can read all last messages that he received, that he or she, received, and automate communication handover. It's easy for the users. And seamless frequency management, of course, important for the operational efficiency. And yes, now we can go through the technical parts a little bit more. And what is the motivation, Rauf, from De Montfort University? What is the motivation of the ATMACA Mobility Management Protocol within this project? Could you continue and help us for understanding more deeply with that?
Thank you, Fuya. So in this part of the presentation, I would like to motivate one of the main contributions of the project. So as you mentioned, in the project, we have several contributions. One of them, for example, is the green route operations. Another one is the HMI. But one of the main contributions is a mobility protocol. So my presentation will focus on this aspect. And to do this, I would like to give you some examples of current air-ground data link services. So you see in this table several types of services that are currently available. So in the left column, you have the name of the services. The first one is CPDLC, which is very well known. This is Controller Pilot Data Link Communication. And in the second column, you see the bearer. So the bearer is the data link. So this is how the data is transmitted. So we have, as you can see, several technologies that can be used for the same service. So for example, we have VDL mode 2, SATCOM, HFDL. VDL mode 2 is based on very high frequency. HFDL is based on high frequency radio. And in the third column, we have the protocols that are used. And you see also here, there are a large variety of protocols that can be used for the same service. So what we can say about the current air-ground data link services is that they are fragmented. They are fragmented not only because we have different types of data links, of bearers, but also because there are multiple protocol environments that can be used in parallel. And also there are different network stacks. So for example, the network stack that is used by VDL mode 2 is not the same one as the one that is used by HFDL or by SATCOM. So that's one of the issues, the fragmentation. The second one is the limited capacity. So for some of the bearers, we have low data rates. For example, for VDL mode 2, the data rate is very low. We also have protocol inefficiencies. We have issues with collision, and this leads to a limited capacity. Another problem is that the mobility is not seamless. So, for example, let's suppose we have a situation where we want to move from VDL mode 2 to SATCOM. As you know, VDL mode 2 is used in the en route area. So when we have visibility, so this is on the ground. But if we move, for example, to the oceanic environment, then we need to switch to SATCOM. And because of this, the switch currently is not seamless because it is done manually. So the aim is to improve this and to make the mobility more continuous. Another problem is the security. So some of the protocols, for example, in ATN OSI, they don't have strong security. They don't have, for example, cryptography, strong cryptographic systems to protect the data. Next slide, please. So because of these limitations, SESAR has supported research towards the future communications infrastructure. And this future communications infrastructure, the abbreviation is FCI, will migrate from the ATN OSI to the ATN IPS. So this means that the internet protocol will be used, and this offers many advantages. For example, we will have more capacity and scalability, and this is required because the demand for the data links is expanding. We will have more capacity and scalability because the internet protocol, IPv6 and IP, they offer routing, traffic engineering. There is also the development of new bearers that have higher throughput. As you can see on the slide, one of them is LDAX. Another one is Aeromax. Aeromax is used in the region of the airport. LDAX is based on cellular technology, so it's much more, it's faster, it's a broadband network. So this will offer more capacity and scalability. We also will have a better multi-link support. As I explained before, the switch from one attachment point, from one access network or sub-network to another one is currently not done in a seamless way. But with the multi-link support, when we have several sub-networks such as SATCOM, LDAX, Aeromax, or other sub-networks, one can the switch can be done automatically. But it's not only this. The multi-link support will also allow to choose the sub-network that offers the best conditions. So the aircraft can be linked to several sub-networks at the same time, and it can decide which one to use. It can also decide to aggregate the data, so to send the data over several sub-networks at the same time. And another advantage is the security aspect, because for IP, we have very strong security protocols. And another advantage is that the integration will be simpler, and also the life cycle cost will be lower. This is also because of the prevalence of IP networks. So there are many engineers that know very well how to work with IP networks, and the ATN OSI now has become some kind of niche stack, and it's not that easy to develop new applications for this ATN OSI. So as I said, the IP-based stacks have widely deployed security mechanisms. There is also the interoperability with IP ground networks, for example, the SWIM, which is the system-wide information management. Next slide, please. But within this new ATN IPS, we wanted in the ATMACA project to look more in depth at the mobility aspects. What is very well known is the terminal mobility. So by terminal mobility, we mean the continuity of an active communication session as the aircraft changes its network attachment. So this is what I mentioned before. If the aircraft is switching, not switching, but is moving from an area that is covered by SATCOM to an area that is covered by LDACs, the continuity of an active communication session, such as CPDLC, can be guaranteed. And this can be done with several networks, several protocols. Perhaps the most famous one is mobile IPv6, but there are other developments. There is proxy mobile IPv6, which in contrast to mobile IPv6 is network-based. So mobile IPv6 is host-based. It depends on the signaling depends on the aircraft or on the router of the aircraft, but with proxy mobile IPv6, it's network-based. And there are future developments or new developments in addition to proxy mobile IPv6. CESAR has funded research for ground-based LISP, locator identifier separator protocol. And the GB LISP, this ground-based LISP, has the advantage that it can be used for inter-domain mobility when we are changing the administrative network, which cannot be provided by proxy mobile IPv6. So this is all well known, this terminal mobility. But what we wanted to add in the ATMACA project are three other types of mobility. The second one is the session mobility, and this is the continuity of an active communication session when it transfers between ground system endpoints. So here we have the possibility for one air traffic controller to forward a communication session to another air traffic controller. And it can be not more than one active communication session. So the first air traffic controller that you see here, A, can transfer all the active communication sessions to air traffic controller B. The third type of mobility is what we call user mobility. And this is the continuity of an active user session as the user moves between workstations or roles. So here it's not the communication session that is transferred. Here it's the user who is moving from one device to another one, and the user can take all the communication sessions to the new device. And finally, the fourth type of mobility is what we call the service mobility. And this is the continuity of an active communication session as the service instance moves to another server or node. So if we have an active communication session which is supported by one server, and if this server fails, then the system should be able to move the service to another or to change the server automatically. So these are the four types. Next slide, please. And I would like to explain now how we can provide this. So we have this ATMACA protocol. It's more than a protocol, it's a framework, and it's responsible for all these 4 mobility aspects. The first thing that characterizes our protocol is that it's IP-based. It's also a protocol that sits at the application layer. So it's an application layer protocol, which means that we don't modify anything in the lower layers. And you can see it as a middleware for ATS data link applications. In the picture left, you see a number of applications such as CPDLC or green route operations that Fuya has presented, but any kind of ATS data link application can be supported by our protocol. So that's why we call it a middleware. And our protocol supports the 4 types of mobility that I have presented. Now, what is the inspiration for our protocol? It's 2 other protocols that are very well known, SIP, the Session Initiation Protocol, and the diameter-based protocol. It's not that we have just taken these protocols and then implemented them. No, it's just inspired by them. So there are some concepts that we took from SIP and from the diameter-based protocol, but our protocol is independent of these. And another characteristic of our protocol is that it's using software-defined nodes, and that helps with scalability. In terms of the architecture of the protocol, it has 2 main components, the data link communication protocol that you see at the bottom. This is what we call the base layer. And this base layer provides the essential networking functions such as data exchange, connection, mobility, and routing services. And in addition to this data link communication protocol, we have DLCM, data link context management, which adds context to all the features that the data link communication protocol can provide. So it consists of 4 nodes or modules, 4 modules. There is a context management module, a session management module, a connection management module, and a mobility management module. And all these modules interact with each other. But the important thing to keep here in mind is that context plays the most important role. So we are guaranteeing all these types of management that I explained before, the 4 types of mobility that I presented before, using the context. Another characteristic of our protocol is that it supports multi-link, and it also can operate over various types of mobility protocols. So we have our own terminal mobility protocol, but we can also use it in conjunction with Proxy Mobile IPv6 or GBLISP. The final thing that I would like to say about our protocol is that it's from an architectural point of view, it's compatible with SWIM, and that's very important for the ATN IPS and the FCI. Next slide, please. So I have only given you the motivation for the protocol, and Sergun, at the end of the presentation, will give more details about the technical aspects. But if you want to find more details about our protocol, I would refer to our deliverables, which were produced as part of this project. So we have deliverable 2.1, which reviews the state of the art in communication, ATM communication networks. We have the protocol design, which is described in deliverable 3.1. The implementation is described in deliverable 3.2. Testing, so we tested the terminal mobility features. We tested them using Omnet++, and the results are reported in deliverable 3.3. And also, we have a deliverable that describes in detail the DLCM part of the protocol. We have published 2 papers. One of them was published in the proceedings of the ICNS conference, and the second one will appear soon, and it will appear in the proceedings of the IEEE Aerospace Conference. So thank you, and I would like to hand over to Rosa, and Rosa will show you some concrete use cases, because I have defined these 4 types of mobility in general, but Rosa will give you some specific use cases.
Okay, so thank you very much, Rolf. Just right. We have been explained that one of the main contributions of ATMACA is this extension improvement of the concept of mobility. We have terminal, we have a session, user, and service mobility. But what that means in terms of operational usage, what could be the benefits or how we can use this into the operational ATM world. So this is what I'm trying to explain now in these sections referred to the use cases. Okay. So yes, let me check. I'm going to speak a little bit about 4 main use cases we have developed up to now in the project. Of course, these are not the only one, because once you start seeing the possibilities, you will see that these are infinite. But because of the extension of the project, we have preferred to concentrate on clear use cases that can show benefits from ATMACA and for its concept of operation. Indeed, we prefer to call them operational improvement more than use cases, because we think this is what we need to understand. What could be the operational improvement that can be delivered by ATMACA and by all these improvements in mobility. So here we have 4. Don't worry too much about the title. They look long and difficult, but I will explain just in a few minutes. So the first one, we call it the Streamlined Advanced ATC and Communication Handover. The second one, we call it Fully Flexible and Customizable Flight Session Management. The third, we call it Consistent and Seamless Data Link Operation Management, including or enabling HMI for pilot and controllers. And the third one is regarding the support of how ATMACA might support green route operation. So I will start with the first one. Okay, so here you have something which all of you will be familiar, that is how flights and the air traffic control responsibility over the flights are transferring today from one controller to another. So you have here the controller, you have here the flight, and when passing the control responsibility from one controller to the next one, indeed there are 3 differentiated processes that can or could be managed or delivered by different providers. We have the transfer of the air traffic control responsibility, that is something normally managed by the air traffic service provider. But we, this is what you have here, we also have the transfer of the data link communication or the communication in general. And this is something that will be managed or can be managed by a communication service provider. But we also have the transfer of the ATM flight data and information that will be managed by an air traffic data service provider. Normally, all these 3 entities relies or come together in one single entity, but indeed there are different ones. So what happened here is that normally this process is complex and is predefined, and it's not very flexible. It is normally linked to predefined schemes, predefined procedures, and also to predefined architecture and technical components. However, SESAR is introduced new concepts of operation that look forward more flexibility and more efficiency in the operation and the transfer and management of the flights. For example, we have this idea of decoupling the provision of the service from the physical placement of the control center. We also have this idea of flight-based division airspace, according not to the responsibility of the controller, but according to the flight characteristics instead of the geographic boundaries. This is the first will be the case of the virtual center, and the second one will be the case of the flight-centric airspace. So these are concepts that are already envisaged and developed by SESARs, and all these concepts indeed demand a very much flexible way of transferring all the air traffic responsibilities, air traffic control responsibilities between the different air traffic controllers, as well as the transference of the communication and the transferring of the data behind them. So this is what ATMACA can do with this mobility concept. It can provide a highly dynamic, flexible, and seamless allocation and transfer of flights between controllers, what might be essential to speed up and to further develop this operational concepts already envisaged by SESAR. So how this might work with SESAR? So imagine you have one controller here. With ATMACA, the flights can be transferred and handed from one controller to another with completely or with total flexibility. So the controller can transfer all of its flights to the collateral, for example, but it can also transfer part of the flights to another controller that might be anywhere in Europe or anywhere in the world, a virtual controller. It can transfer all or part of the flights or just one single and individual flight to another controller, independently where the controller is physically located, or also independently whether the control is based on sector or on a flight-centric approach. And this can be done in a totally dynamic and flexible way. How is this possible? Okay, this has to do with this idea with the concept of session. Indeed, we call it sometimes also flight session. A flight session or a communication session is a logic end-to-end communication relationship between two or more entities. And here in ATMACA, we give it an operational twist because we establish a single univocal relationship between a communication session and a flight. So when the flight is moving through the airspace, passing from one controller to another, crossing the airspace, and passing through the ATN system and to the communication infrastructure behind, the flight session is managed and moved through this infrastructure by ATMACA in the same way that the aircraft is moving through the airspace. And in the flight session, we link everything that has to do with the flight. For example, you will have the communication, the data link communication of the flight, the current and the past one, the historical. And we can also have data regarding the context of the flight and information that can be useful for the following controller. We can have the planned trajectory. We can have the executed and real trajectory, even the radar data of or information from the previous sectors where the flight has been passing out, okay? And all this information can be transferred to another controller in this flexible way you see here, independently of the physical infrastructure behind. Okay, so that will be the first case, for example. The second case, we call it fully flexible and customizable flight sessions. And this has to do with this capacity to manage the flight session, guaranteeing and maintaining a seamless transition of the flight communication sessions through the airspace management. ATMACA manages the session and enrich the flight session and upload and improve the session with all the information related to the flight, so that when the flight is moving through the aerospace and passing through the communication infrastructure and from one sector to another, the flight session is enriched with all the information, the communications, and the historic of the communication of this particular flight. So this information is available for the next controller or for other stakeholders to which we are sharing this information. To come back to this idea, let me show you some correlation between the real world and ATMACA concepts. Here you have the aircraft with the communication, the flight data, all the context information related to this flight. These, for ATMACA, are flight sessions. We have our controllers and pilots, our actors, with the different roles and functions they implement. For example, the controller can be a terminal controller, a tower, a departure, or an en route controller. For us in ATMACA, these are defined as roles. And we also have workstations or working positions that in ATMACA we name it as workstation. So ATMACA implement functionalities like, for example, the session to role mapping, that allows to map sessions with the roles of the controllers and the pilots. It also implements functionalities like role assignment dynamics that allow controllers dynamically log into different workstations and assign themselves a particular role. Okay. It implements also functionalities such as session display, flexibility on showing the different flight sessions that are tied to the controller role, and also authority transfer workflow that allow to transfer automatically, internally or externally, the session, the flight session, once it leaves the jurisdiction of this particular role or air traffic controller. So all these things together allows interesting operational improvement. For example, you will see here, there is, and I think my colleague Sergun will explain a little bit about that later on. It includes an automatic present management, because the protocol provides present information on the aircraft and the controllers immediately after registration in the system. So it's quite interesting to know which automatically which aircraft are under your jurisdiction and which is the status and the role of the controller and the workstation that are active in the system. But moreover, we have other interesting functionalities. Like, for example, you see here we have one controller working in one workstation and delivering service, providing air traffic control services to different flight sessions. This is more or less what we have today. We have one controller working in one workstation with a set of flights. So what will be new or different in ATMACA? ATMACA will allow this for sure. And this controller will not only be managing flights, he will be managing flight session. That means that he will have access to all the information within the flight session. That means communication, past communication, session information, context information, flight plans, everything that can be linked to the session. So what could be different? Here you have a different case. We can have a role that is managing multiple aircraft or sessions in multiple workstations. This is very much interesting because it enhances mobility and allows things like, for example, the controller can manage the sessions from different devices, from different workstations. It allows or enhances mobility because it allows that the controller can move in or out of the control room, can move from one station to another and keep its role and the sessions that are under the control linked together. It also allows that a session can be duplicated, and this might be very useful for things like contingency, when part of the services or the infrastructure are lost. The sessions linked to this controller will keep linked to this controller. So he can move to a contingency place or a contingency center. And the session, the management, the configuration, it will move with him. This can give also support, for example, in the case of shadow mode. It could give support in the case of a multi-sector controller, because the sessions can be duplicated in different devices. So multiple roles can visualize all those sessions and all the information related to those flights. Of course, only one controller will have a responsibility over the flights at any moment, but the information can be shared. So it would be useful for multi-sector planner, for shadow mode, for supervision of the control room, or for supervision during the operation, supervision during training. You can see there are multiple possibilities. Okay, and here you have a third possible scheme in which you have multiple roles into one single workstation. This is a functionality that allows things that we could also do today, but with much more flexibility. This will allow, for example, controllers integrate roles or split roles. For example, in an airport, you could integrate, when the traffic is slow, the role of the departure or the different roles of the controllers in the airport, or you could integrate roles of sectors en route, or you could split those roles. We already have this possibility, but this will allow to do it with much more flexibility. Okay, so this was the second case. And just let me show you some information, or give you some information about the third of our cases. I think that these three ones are the more important. For this case, we have put the focus on the fact that there is a huge number of data link applications, and probably there will be increases in volume and scope also in the future. And sometimes manually handling some events associated with the data link, like the log on or log off process, or dealing with disconnection and discontinuities, is something that could increase a lot the workload of pilots and air traffic controllers if they are not handled properly. ATMACA will allow that all data link services and applications can be managed through a very simple supportive interface for pilot and controllers, in a way that pilots and controllers will only need to open session in ATMACA system at the beginning of their flight or the duty period, and the system will allow automatically and manage for them all these log on, log off process, disconnection, disconnections, when the data link services or the infrastructure are not available at a certain time. So to illustrate the situation, here you have a flight that is logging in a particular data link application. So the controller, the flight is logged on, but it might be suffering some disconnection or failures or gaps in the data link connections to the flights. And for the pilot and controllers, that means that this disconnection has to terminate and initiate again the connectivity, the connections with the controller below. If it is only one flight, if it is only one time during the flight, it will not be too much. But the thing is that as data link are increasing in volumes and scope, this could be something unmanageable. So what will be doing ATMACA for us? What ATMACA will do is that the pilot and controllers, as I said before, only need to open the sessions at the beginning of the duty or at the beginning of the flight. And the system, because of the continuity of the flight sessions that is guaranteed by ATMACA, the system will automatically manage all these intermediate connections and disconnection of the required data link services for the pilot and for the controller. These are just 3 examples. Of course, there could be more. And what I pretend here was to transmit a little bit the operational utility, how we can use in our daily ATM work, how this enhanced mobility concept can be used and what benefit can bring to the community. And that's all from my side. I will pass now the floor to the Captain Sergun. And expect that he will give you some more technical background on how ATMACA project and protocol works.
Okay, thank you, Rosa, for your valuable information. And then thanks to all speakers before me. They give you a kind of conception, operational concept, and then a technical concept for us. Now I'm going to talk about the how we plan to make it happen, actually. So in technical wise, but unfortunately I have a limited time, so I'm going to keep it short, but I will try to give you a kind of spot information for you for the technical realization of the technology itself. So whatever you see over here is as we said before, the ATMACA network is all about the software-defined nodes. So whatever you see on the block diagrams, they are software instances, entities. So they can be either on co-located with one hardware platform, or they can be standalone with one hardware platform. It depends on the network configuration. So let's start with the management station. Management station is a kind of normal station, but it is used by the airspace owner or authority. They define their airspace structure digitally in the network. So once they define it, they have to download to the brain of the system. I call it the ATM server. So as you see over here in this diagram, that you can see that we have a number of control areas and FIRs and everything, and they have all digitally defined in ATMACA network. So, and all of these areas and the flight information engines are controlled by a software-defined nodes over here. And let's see the management station. Once the airspace structure digitalized in the network, so they download the airspace structure to the ATM server. After this point, ATM server knows about the what kind of airspace structure we have. It knows about the sectors, it knows about the control zone, control areas, terminal areas, everything you name it. So it knows about everything. So after that is orchestrate the network itself. But first of all, you have to go through the registration process. You have to be authenticated and authorized, first of all. So the ATMACA server is the brain, I call it, like here. So we have authorization policies as well in addition to the airspace structure. So authorization policy is linked to the external network system out of the ATMACA network, actually, I should say. And after that, one of the ATMACA node is startup. They should introduce themselves to the ATMACA server first of all. Let's talk about the ATC agent. Once the ATC agent is initialized, it should be registered itself, and then it gets the provision data. The ATC agent is a kind of session anchor point, and then it's managed the connections between the ATMACA nodes within the network. So it's all about the connection management. And then you can have intra-area handovers, intra-area handovers, and then some triggers. You have some triggers points in the network as well. And so you're tracking the IP changes in the network or connection changes in the network, those kind of stuff. Basically, it's a routing and forwarding agent in the network, actually, ATC agent in our network. So first of all, you register to the ATM server, you define yourself as a what kind of agent you are, which area or something like that. So ATM server download the provision data. So ATC agent can be responsible or multiple facilities or multiple control areas. All of the information regarding that area is downloaded by the ATM server. That's it. It's a kind of dynamic provisioning. And after that, we have CM agents. So until this point, ATC agents are about the connection management. So we can provide a terminal mobility with the ATMACA network by using the ATC agent. But when we come to the CM agent point, actually, it's a context management agent. It is responsible for user mobility and then session mobility too, and at some point the service mobility. So CM agent is more localized servers. They are located in the facility itself. Let's say if you talk about the airport tower or airport area, airport domain, you can have one CM agent. If you're talking about the airline, you can have one CM agent over there, or you can combine them depending on the expected traffic density. So if we talk about the CM agent in here, so it manages all of the context. So the context is a very important key point over here. If you remember the movie Avatar, all of the users within the ATMACA network, they call predefined user, I call them avatar, they are already defined in network itself. What does it mean? So if you have a ATC roles like a delivery, ground tower, approach east, departure, west, whatever it is, they are already defined by the ATM server in network. So what you are doing normally, when the air traffic controller log on to the network with its machine, then first thing to do, it's a association one of this user, something like that. So let's continue the stationer client. So again, the CMA should be registered for the ATM server and provision. Then after that, we have a stationary client. Stationary client normally used by the air traffic controllers. But in here, the stationary does not mean that it's a staple or fixed client. It can be mobile as well. But the stationary means over here, the devices can be interchanged, but the point of attachment never change. So that's why I call it stationary client. So this stationary client always connected one ATC agent. In contrast, the mobile client, they can change during the mobile event their point of attachment. They can change the ATC agent connection during the mobile event. But stationary client, they never change the attachment to the ATC agent. So it's attached from beginning of the life cycle, then stay there. But you can interchange the machine, everything. And stationary client here is user and role based. What does it mean? So when you use your terminal to log onto the system, so you just pick up a kind of role for yourself, which is avatar for you. Let's talk about the tower responsibilities. So we have three roles, delivery, ground, and the tower. So when you log into the system and you authenticate it by the external server over here, this is not out of that magic concept. And after that, you are able to choose your role. So when you choose the role, let's say the ground controller, then the system associates you with the ground controller. So you download all of the context that already done by the previous controller to your workstation. So you continue your work with that context, which is already built up by the previous air traffic controller. Then after that, you can take over the air traffic management. So again, the registration and provision is always done by all of the ATM servers, all of the ATMACA nodes. And if we move to after registration, all of the clients, they should log on to the network, because when the provision data arrive from the ATM server to the stationary client, they download the provision data or uploaded by the ATM server. So depending on that provision data, they will know which area or which ATC agent will be responsible for them. Then they basically log on to the ATC agent. When they log on to the ATC agent, the ATC agent build up its routing and forwarding tables depending on the machine in request, whole login request. So after the user data, all of the user data, which means that which sectors will be responsible for those, sometimes those kind of information will be downloaded to the stationary client too. So after that, the stationary client will be ready for operation. And if you talk about the mobile client, it's almost the same. Again, the mobile client, let's talk about the aircraft pilot itself. So when they authenticated with their operator authentication server, in this case, they have to take an avatar for themselves. But that avatar is not a kind of air traffic controller roles. It's a kind of call sign. So those call sign, which will be automatically generated by the ATMACA network when the flight are filed. So whenever you log on to your system via your HMI, you will see that the call sign. So you associate yourself with that call sign. So the networks knows you with that call sign. But normally, two different machines in the cockpit, one captain, one first officer, they use two different machines, but same user in the network. So this is one of the contribution of ATMACA network. So we can move or we can forward all of the messages to different machines or something like that. So that's why we have a CM agent. CM agent controls all of this context. So I call the context a kind of domain-based naming. I mean, in ATC perspective, it's a kind of roles or sectors. In flight deck perspective, it's a kind of call sign. So these are the context. So again, the registration, but look at over here. After registration, you have authorization section, which means that mobile client sent flight information, registration, call sign, departure, destination, whatever it is, all of the specific unit that flight. So with a kind of hash mechanism, you just generate a code, and that code is transferred to the ATM server. And after that, ATM server using same the encoding mechanism, and then retrieve that flight information and ask to the external server if there's a flight, really there's a flight is filed or not. And after that, the provisioning data is downloaded to the mobile client. And depending on the departure airport, mobile client provision with the proper ATC agent. If you are still sitting on the Madrid airport, you will be connected to the ATC agent in Madrid area. If you are sitting on the Istanbul airport, you will be connected to the agent to the Istanbul area. So that's why that provision and flight information is very important by the ATM server, because all of the provision data depends on that. So the flight information is forwarded to the ATM server with the registration message. So again, the logo and then the user data is retrieved. For the application server, so what we are talking about, we have the applications or services can be either transaction-based or session-based. So let's say, and then the applications and services can be either client-based or server-based. So if we talk about the CPDLC does not reside on application server. They live in client itself. Or if we are talking about the weather information, so they will live in a server or something like that. So based on this distinction, and then if the service is a session based, so we managing the session as well. If the service is not, it's a transaction based, it doesn't matter. Then one-time message sequence completed. Once the message sequence completed, then the service is ended, sort of stuff. So we are able to support two types of services or application in our ATMACA network. So this is the basic idea, how it works, how it interact each other. And let's move to how we do it actually in the more lower layer. So we have an ATMACA header and DIS, the data information exchange. This gives a kind of power, actually, first of all, but let's go to ATMACA header over here. And we have application ID and command code. So I should say that ATMACA does not provide an application to you. ATMACA provides a framework for you, for application designers. So any kind of application can be designed on top of it. And by using the ATMACA protocol rules, they can communicate with the peer entity. So that's why we have an application ID and command code. If we talk on CPDLC, application ID is the CPDLC ID, whatever it is, and it can be command code, it can be ACM code, it can be whatever the message that you can send via CPDLC, any kind of command code. So that's the application defined in the ATMACA header. So when the message is received by an intermediate node, which is in our case ATC agent, let's say, so ATC agent will know which application arrived by the application ID. If the CPDLC message arrived to the ATC agent, which means that ATC agent does do nothing about the content of the CPDLC message other than the forwarding to the proper endpoint. So again, in the client side, when the application identified, and then if the application is already reside on that client, so it's able to open the message and then process accordingly. And the DIX, I mean, Data Link Information Exchange, it is the power of ATMACA because let's go to header, and every application can define multiple data link information exchange over here. Let's talk about the CPDLC again. Let's think two different organizations. They develop CPDLC based on specification, same standard. But one of the organization, they want to add some additional feature. So in that case, they can define data information exchange as well within the framework, and they can put vendor ID. So you can make it your application feature rich. So an interoperability issue. So if you have an application that more feature rich, and if you sell someone, then if you want to talk to each other, or if you want to use that feature, you have to have that CPDLC application from that vendor, actually, if you need that feature, something like that. So you can control, or you can differentiate your application from the standard specification without changing the normal standard, but adding some additional feature, and then you can specify your vendor as well in this data link information exchange message. And so we are working as a domain-based addressing and routing. So which means that we define the ASP structure, all of these, the email-like addressing or something. So on the left side, you can see the sectors. And then the function is the first part, or role, or whatever, I mean, sector name, whatever you call it, is a delivery in our case, in this example, right? So Bravo Hotel X-ray, which is Birmingham Airport, .uk in the England, .atm air traffic management network. So in ATMACA network, you can have multiple network, but they don't interact each other. So you can define multiple domains within the ATMACA network. So which means that if I'm going to talk to delivery guy, and I'm using this domain address, I don't have to know the IP addresses there. I don't care as a aircraft or as a flight deck user. I don't care which IP address it is. I only need this domain name. So ATC agents are responsible to match it, right? So it can forward the message to delivery, Birmingham, UK airport, ATM, whatever, forward the message. So again, for the TMA domain, same idea, and then en route domain, the same idea. So we just identify the location of the context or sector, and while locating, we can identify the country and then which communication domain. If you go back to the flights, so we can have as you know, in the ACARS network, that the pilots can connect it to their operational center. So that's why we have two different networks over here we define. And the first one, Turkish Airlines 1 Alpha Bravo, which is the call sign, at THY, which is Turkish Airlines, at TR, which means that this Turkish Airlines in Turkey, operated by Turkish, and then it's Turkish Airlines, and within the ATM domain, air traffic management domain. So this address is used for ATC communication only. If you go back, if you look at the down in TK1699, which is the internal number of Turkish Airlines flights. So THH, the Turkish Airlines TR, Airline Operations Center. So I can reach, or my operations center can reach me via this address. So ATMACA network knows all of this mapping, IP address and everything within our definition, actually. So we are using domain-based addressing and routing in our network. So Rosa talked about the presence management. It is important because you have to know that status of the, even for the air traffic control, it can be available or not. So, or in the HMI, you can see that the VHF frequency as well. If you see that it's away or offline, so you can try to contact with them with the VHF frequency, with the voice communication or something. So all of this information can be able to visible to the pilot in the cockpit. And for the air traffic controller point of view, again, you can see that the status of your the flights under your control or something. So we have a kind of watchdog mechanism and then within each packet, we just measuring the health of the network or connection itself to be able to make it make another secondary connection before lose the connection for the previous connection endpoint or something. So it is very important for the it is important, and watchdog mechanism is very important for us in our design. So terminal mobility, let me show you over here like this. It's already defined to you guys. But first of all, when the aircraft is or when the flight is started or initiated, so register message is sent to ATM server, and then we have a log on to the area 1, which is the sent by the ATM server to us. And when the network is changes, handover happens, so update IP our new communication address over here. And if we're changing the area, so we are first of all make connection, then break connection, make before break concept in here on ATMACA network. And after that, we're moving normally update, IP address is change, and IP address is change, update. So that's why a TC agent knows, a TC agent build up constantly its routing tables. So that's why all of the endpoints communication can be done with domain naming. All mapping isn't done in the ATC agent. And the session mobility, Rosa again explained it. But the idea in here, every user delivery or every predefined user or every avatar, every context, whatever you want to call it, are previously registered and log on to the ATC agent. It's done already. And what you are doing data transfer authority. So the sessions are transferred from one ATF control to another, and again from one to another. So whole flights can be managed between air traffic controllers without pilot intervention. And user mobility in here, we have 3 scenarios. On the further left, you have a same air traffic controller, different machine, and same user are attached. Okay, so one air traffic can have one workstation, and then he can log on and attach, and from iPad or whatever, and a mobile tablet PC, so attach them. So ATMACA or CM agent can able to fork all of the messages for delivery guy or for delivery user, 2 different machines, 2 different machine or workstation. And second scenario, 2 different air traffic controllers, 2 different machine, and again same user or same domain name. This is sometimes very useful for the air traffic controls when they do want to shift change or something. The other one, for example, in here, ATC3 can be in monitoring state, and the other one is a controlling state, and then it can monitor the traffic and messaging everything, then take over the air traffic management in that area as well. And the third one, early in the morning, you can merge the sectors, right? So let's say ATC4 can merge 2 different tower operation management in one machine, tower 18 left or tower 18 right or something. So it can merge it to the one machine and then monitor and communicate the aircrafts or something. So this is the scenario, so user mobility for session point of view. But again, we don't only transfer the session or communication session, we can move all of the user settings as well. And source mobility can be used for different scenarios, but most of the time is the balancing, load balancing, or in the failure scenario. Once the service is requested and service delivery started, so we can continue to retrieve that service. If it is a session-based service, we can continue with this service from the another application without noticing it. And again, this is another issue. If the aircraft is flying from A to B, so always we guarantee you can have or retrieve that service from closest point of attachment. I mean, so every time you switch the service from one server to another server, it's close to your something, or you lose this connection with the other server, so you can switch back to the switch to backup server or something. So this is the another utility of that ATMACA.
Yes, thank you very much, Sergun. We already achieved our presentation did, and now time is go very fast, unfortunately. Just I would like to talk about and explain about our validation plan with two sentences only. We will have real-time simulation test for HMI, or of course we will have emulation and simulation test for the validation part of the protocol, and at the end we will have real-time flight tests with the Turkish Airlines flights. During this April, we are planning to test our protocol communication in the real environment with the real Turkish Airlines flights, and we will present it to you, our result, and deeply information about the validation part of us. So I don't want to take your time much more. Just there was some questions, and we tried to answer them in the chat. And now, if you have additional question, you can directly send us any email to direct us, and please visit our webpage and follow the LinkedIn account. There is an ATMACA LinkedIn account. And the answers of the questions and all webinar information will include in our website. And please follow LinkedIn account. And someone was asking about our public documents. We will, of course, share with our webpage for our deliverables and for our conference paper and as in our webpage. And when we upload it, we will announce via LinkedIn. And yes, I'm not mute. Sorry, Marco. Someone was say that. I hope everyone hear me. So please follow us. You can just take our QR code and follow. So thank you for all speakers, and I hope it is very interesting for you and explain well. And we are looking for all of you for our next webinar. And please, we will invite to you for next webinar, and please come. And please visit our LinkedIn account and webpage for the all information detailedly. And don't hesitate to ask directly via email or message. Thank you. And Philip, we are ready for closing ceremony, I think.
Closing ceremony is to thank you, all of you, for a very interesting webinar, and also for a very good running of this webinar, because there were many of you presenting your own area of expertise, and it went very smoothly. So thank you very much. Very interesting subject connected to a lot of things happening today, and thank you for answering the Q&A. For the people, we were up to 200 people connected today, so you were very popular, and I can assure you that you will have still more people connected to the webinar that you announced for the autumn this year. So we will be happy to organize that together with you. So thank you very much for this webinar today. And for the remaining participants, of course, we will share everything, the documents that the team has presented together with the Q&A, the question and answer, because a lot of them were answered in writing. So everything will be available, and please reach out to us. So thank you very much again to all of you. Very interesting. And I wish everybody a good end of day, and see you in one of our forthcoming webinars, and latest in the next ATMACA webinar. Thank you. Bye-bye.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.